Aloha.
All right. So welcome to the first, hopefully, annual Lava One conference. Thanks, everyone, for coming.
Woo!
I hope more people will show up. More people signed up, so I don't know if they will come, but I hope so. And what is there to say? I don't know. There's still breakfast. If you're hungry, grab more. We'll leave it here for a while. I think lunch comes at 12, and then so every session it has an hour slot. You can use that hour however you want. You know, talk 30 minutes and then, I don't know, answer question for 30 minutes, or I don't know. So the plan was 45 minutes talk, then, you know, a break, whatever.
Yeah, you're not getting that break in my talk. Good luck.
So the only thing today, we're going to the luau. So we should probably finish this by 4, so we can go over
turn
there.
that down?
Tomorrow we can, you know, stretch it out a little bit. Restrooms right across the hall. There's also, we have water here too, but there's a water fountain out there where you could fill your water bottle. What else? Use the pool, use the beach, whatever. That's it. Yeah.
So awesome.
So, and this is Josh, and he's starting with Cloud Native Java.
Thanks for having me, man.
Thanks for
Appreciate
coming.
it. Hi, everybody. Aloha. Good morning. Well, we've got an hour. We got an hour, right? How many of you are speakers? Mm-hmm. How many of you are students? Okay, so 3 are students, and 3 are practitioners. I'm debating whether I should just throw some of the new stuff, or just we can cover solid ground in comfortable Java, or if anybody wants to see me fumble with Kotlin. I don't know. We could. You want to see me fumble with Kotlin? How many of you have heard of or know somebody who knows of Spring? I'm just curious. Okay, I'll go ahead and the most important people in the audience didn't raise their hand, so I'm going to go ahead and just do the safe and steady Java version, and we'll go through that one. Okay, good. So we have a lot of stuff to cover today. The whole point of this this talk is to go through a lot of stuff, and it's not, mind you, to record or remember everything that we're going to type or do. It's to appreciate more that it is possible, right? So there's a lot of concepts, and I'm going to show them. I'm going to apply these technologies in service to these concepts. But keep that in mind. The goal is not to remember everything I type. It's to remember why I type, right? We're going to go ahead and go through a lot of stuff. And so as a result, I want to encourage you to take note of that GitHub repository there for your own reference, for your own edification for later. That's there so that if you have any questions, comments, feedback, whatever, don't hesitate to peruse that code. And if you have questions, again, don't hesitate to reach out to me. I'm very happy to engage, happy to answer questions online. Just show of hands, how many of you are on Twitter? I'm curious. It's 2018 Twitter. Yes. All right. The rest of you, get on it. Get on it. It's the new IRC. It's the great place to be. It's where all the developers that drive the open source that power your business are. And if you want to engage, you owe it yourself to be there. What about email? How many of you are using email? Email. Anybody here? Email. No. Good. Okay. Yeah, no, I'm not a big email fan. But if that's the only way you can get to me, and you've already exhausted faxes and carrier pigeons, then that'll work, right? Okay, so there's the coordinates. If you have questions, comments, feedback, whatever. A little bit about myself. My name is Josh Long. I'm a Spring developer advocate on the Spring team. I'm an open source engineer and contributor. I've had the privilege, I say, of being a open source contributor to a number of different Spring projects over the almost 8 years now that I've been on the Spring team, and longer before that. I've been a contributor to projects like Spring Boot and Spring Batch and Spring Cloud and Spring Integration and other open source projects like Timeleaf and Activity and Vaadin and so on. Lots of different open source contributions. I have the dubious distinction of being the number one, most prolific, most highly acclaimed, most lauded, most visible contributor of bugs. But still, number one contributor in all the projects to which I'm party, right? More bugs per commit than any other engineer on those teams. It's not exactly something I'm proud of, but it's something. I'm also, as a Spring developer advocate, I spend my time in front of organizations trying to help them build better software in terms of the JVM and, of course, the Spring ecosystem. As part of that, I spend my time in front of people like yourselves. It's so great to be here, by the way. And I write books and I do training videos. So I just completed my 7th training course. It's called Applied Continuous Delivery Live Lessons. It's by Pearson, Addison Wesley on the Safari online technical portal. You'll find it there. It's a Safari, all you can, it's a Netflix style, all you can eat buffet style subscription to technical content, books, videos, that kind of thing. And I've also just finished my 5th book. My 5th book. Every time I've ever written a book, I've always sworn I'll never do that again. That was the stupidest thing I've ever done. And here we are, 5 books in. Something about recidivism and books and whatever. But the point is, that book took a lot longer than I'm proud of. I wish it had not taken so long, but it couldn't be helped. It couldn't be helped. I'm just going to go ahead and just leave that here for you now. It couldn't be helped. We spent about 6 months writing the book and another year and a half deliberating the animal that was going to be on the cover. Anybody who knows anything about O'Reilly books knows that it doesn't matter all that much at all what's in the book proper. It's everything to do with the animal on the cover. And so we spent a long time debating that choice. We settled eventually upon the blue-eared Kingfisher. The blue-eared Kingfisher is a bird with blue ears. Did you know birds have ears? It's a bird with blue ears from the Indonesian Java Islands. It's a bird, and birds fly, often through the clouds. So it's a bird that flies through the clouds that is native to Java. It is indigenous to Java. It's a cloud native Java bird. Never mind, it'll come. Give it time. Give it time. So there's that. And I work at Pivotal, and you may recognize some of the iconography on this slide representing some of the open source projects to which we contribute at Pivotal. We have a lot of great open source. We love the open source at Pivotal. But let's be very clear. At the end of the day, it is not the main reason that I or anybody else do what we do. It is not the thing that drives us. It is not the reason that I spring out of bed in the morning. What I love and what we all care about more than anything else at the end of the day is helping organizations, community members, customers, etc., build better software faster, and to see that software delivered into a production environment where it benefits the customer, the ultimate stakeholder in that software. And we know that a lot of organizations struggle with this. They know that they need to go faster, but they struggle with how. They know that they need to go faster, but they struggle with how to capture that speed and how to do so in a safe way. They look around the ecosystem and they see these large organizations, these behemoths, and they seem to be delivering at incredible speeds. So do the small startups. So what's the secret? Why do some superstar companies deliver software very quickly and safely, and yet others struggle to do so at similar sizes? What's the secret? And I think size is part of it, but it's not the size of the organization so much as the size of the team working on the software. You see, the large companies, the Netflixes, the Googles, the Amazons, whatever, these companies are large, but they deliver as though they're small. They deliver with small teams. They deliver with small teams working on small code bases. The smaller the code base, the smaller the scope of any particular change or feature or addition to the code base. The easier it is to test that change, to reason about the impact of that change. The smaller the size of the code, the easier it is to see something go through concept all the way to customer. And so this is not even a particularly new insight, by the way. Mel Conway in the 1970s seized upon the insight that software is a mirror image of the communication patterns of the organization that built it. Put another way, crap in, crap out. If your organization is dysfunctional, your software will reflect that dysfunction. If you improve the organization, if you improve the communication in the organization, the software will improve as a result of that. They've done numerous studies in the intervening decades to sort of confirm this effect. They took open source software and they compared it to proprietary software of analogous form and function. Imagine you had the opportunity, and I use giant, dripping, sarcastic air quotes here when I say opportunity. I mean, ridiculously dripping. I mean, just indulge me here. I could not forklift these air quotes and the dripping irony into this room if I had to. They're just too big. But imagine you had the opportunity, again, air quotes here, to look at the source code, hypothetically, for Microsoft Office. What would you see were you to stare into the void, stare into the chasm of that code base, and then compare it to something of hypothetical form and function, analogous form and function, something like OpenOffice. What they realized in these studies is that if you were to compare something of analogous form and function, like, for example, Microsoft Office or OpenOffice, and again, hypothetical, I've never had the privilege to look at the source code for Microsoft Office, but what you would find is that the open source software tends to have far more modularity, far more componentization in the source code. And this effect makes a lot of sense when you think about it. You see, people working in open source are, they're distributed all around the globe. They're sat in different places all around the planet. At each corner of the planet, they are working at different capacities, at different leisures, at different, availability. Some people work in the mornings before they send their kids off to school. Some in the evenings after dinner or whatever. Or some people on the weekends. Some people not at all for weeks at a time, and then they burst and they contribute for a few days solid. Their contribution schedule is very different. It's sporadic. It's not predictable. So for these people, for people working in open source, the cost is in synchronization. It's communication. How easy is it for people in that team, that organization, to get on the same proverbial page? It's very difficult for everybody in an open source project to get in the same room. And if you're sufficiently distributed, then it's almost as impossible to get everybody on the same phone call, right? If I'm sat in PST in California and I'm talking to somebody in China, Beijing Standard Time, that's a joke, friends. One time zone for the whole country. Anyway, if I'm sat in China and I'm working with somebody in PST, somebody's going to have to stay awake late or wake up early. There's no way we're both going to be available in working hours, right? This makes it very difficult for people to engage, to communicate. The synchronization bottleneck is the reason that things are slow to happen. This is different from, for example, proprietary software, where you're all sat in the same room, sat in the same office, speaking the same human language, at the same office hours, more or less. Obviously, there's some guy like me who strolls in a half hour late, but basically, you're all in the same place. In this case, if there's a question or if there's some sort of discussion point, you can swivel your chair. You can say, Jane, I had an idea. Maybe you could help me. I need your help. I'm trying to see if this could work. I don't quite understand this code. Can you help me out? Right? We can have a very easy, very, very quick conversation. Maybe I'll walk down the hallway instead. But either way, the cost of synchronization is nil. Next to nothing. The cost of synchronization is nothing. So I don't have to do very much work to affect change in the code base. If I change something here and it impacts something over there, no problem. I can talk to the person that it'll impact right away, no problem. This is very different from open source. So what open source projects tend to do is they tend to be far more modular. They realize that if they stabilize the surface area component boundaries of the code base, then other parts of the organization, other parts of the team can depend upon that stable surface area and pay no attention to what is inside that component boundary. They're able to change the software independent of other parts of the team as long as they can depend on the component boundary between modules. That componentization stands in place of actual communication, of actual synchronization. There's some, of course, communication. They have to establish the contract between modules. But once that's done, they can move independent of each other. You have now the ability to release software, to release changes independent of other parts of the organization. This is important. This means you've unblocked teams. So what we're describing here is small, singly focused, independently deployable pieces of software, small batches of work. When we talk about this to its logical sort of extension, these days we talk about microservices. Microservices are a small, singly focused, independently reusable batch of work that can be independently deployed. And when we say independently deployed, we mean over the network, right? That means I can deploy one process here, another process there, and they're talking to each other over the network. Microservices give you organizational agility. They give you the ability to go faster, to deliver better software faster. But once you move to this architecture, you're going to run headlong into two big pains, two big headaches. The first is how quickly can you, from 0 to 60, how quickly can you stand up a new production-worthy service and all that implies? One service, how quickly can you deliver all the business differentiating functionality in one piece of code? And that includes things like security and observability, heartbeat detection, failover, load balancing, replication, all that kind of stuff that you care about. Not to mention racked and stacked servers, virtualization. I mean, all the stuff that you care about. Everything that's required to stand up one service. How quickly can you do that? If it takes forever to do it, you won't do it. right? There's a cost-benefit analysis that you all engage in. We all do. It's rational. I would do the same thing were I in your position. That cost-benefit analysis makes it so that I won't spend an inordinate amount of time if it requires too much work. Most organizations that I've been to, not yours, surely, not yours, but most organizations that I've been to have, and again, I know it's not yours. It couldn't possibly be yours. Most organizations that I have been to have the dreaded wiki page, the wiki page with 500 easy steps to production. That wiki page is the enemy of velocity, is the list of non-functional requirements that we need to address before we can deliver line 1 of business differentiating functionality. So we have to get past that. We have to automate and codify all that as fast as we can so that the cost of standing up a new production-worthy service is nil. Once we've done that, now we're hopefully in a good place. We've got the ability to stand up lots of services, the result of which will be just that, a proliferation of services. And these things are going to talk to each other. And presumably, they're going to be talking to each other over the network, and that introduces the complexity of distribution. You've now got a distributed system on your hand, and the complexity of building a distributed system is not to be ignored. You're just going to ask, or rather, you're just going to invite more complexity and more pain into your life if you're ill-prepared. Thankfully, we stand on the shoulders of giants these days. There's a lot of good patterns out there that we can use to serve these use cases, and that's what we're going to talk about today, mostly. So we're going to build a new system. We're going to build a new piece of software today. We're going to go ahead and start our journey today here at start.spring.io. How many of you know start.spring.io? This is my second favorite place on the internet. My first favorite place on the internet, of course, is production. I love production. You should love production. You should go as early and often as possible. The weather is amazing. It's the happiest place on earth. It's better than Disneyland. But if you haven't already gone to production, then you can begin your journey here at start.spring.io. If you want for inspiration in the early morning before a cup of tea or coffee, start.spring.io. If your children are restless and can't sleep, start.spring.io. And if you suffer from indigestion after a long night of alcohol abuse and PHP, start.spring.io. So we're going to go ahead and build a new application. I'm going to call this the reservation service. I'm not going to linger too long on the nature of the service. It's going to be a service that manages, guess what, reservations. We're going to go ahead and use Spring support for building web applications. We're going to use the config client here, the centralized configuration support. We're going to use Eureka for service registration discovery. We're going to use Zipkin for distributed tracing. We're going to use Actuator for observability requirements. We're going to use Lombok to take some of the tediousness out of Java proper. And we're going to use JPA, the Java Persistence API, because I make terrible life decisions, so JPA. Now, we need something with which to actually persist our data. I need a database. So I'm going to use H2. Now, H2 is an in-memory, embedded SQL database. It makes it an ideal choice for demos, right? That's what we're doing here. That's what's about to happen. So demos. It's great for demos. It's going to, every time it runs, it's going to exist, and then as soon as we kill the process, it's going to lose all of its data. All the data that you've got in the database, it's going to be gone, wiped from the face of the earth. It'll never have existed. It's going to be gone every single time we restart the process. All the time, we're just going to lose data. In this way, it's very similar to MongoDB. You're just going to lose data all the time for no reason at all. Okay? Now, I think we've got enough here. I think we've got enough to just to make this work. Lombok, H2, discovery, config, Zipkin, Actuator. That serves me, I think. Let's go ahead and hit generate. Now, that said, there are a number of different choices. Were you so inclined, I'd encourage you to peruse this larger list, and you'll find a number of different things you could elect were you so inclined to your project. But for our purposes, it suffices to leave the things as they are. So now, let's go to here. I'm going to open up this project in my IDE, and it doesn't matter what IDE you're using. All of them are great choices. Eclipse is a great choice. NetBeans is a great choice. IntelliJ is a great choice. They're all great choices. Indeed, these days, a lot of things are being implemented as language servers, which are IDE agnostic. So if you've got, for example, the Spring Boot support from Spring Tool Suite, which has been now extracted into language servers, you can use Visual Studio Code, Emacs, you can use Atom. I mean, these things all support a nice experience for Java developers. But I'm going to be using my clutch here, which is IntelliJ. So what we have now is a new build. It's a new application. Can you see that font? That's a little too small. Let's make that a little larger. I can just barely see it myself. All right. How's that, friends? Can you see that in the back? And by the back, I mean the front. Yeah? Okay, good. Okay. All right. So we have a number of different dependencies here. We're going to go ahead and comment out some of the bits that we don't need just yet. We'll return to them later, I assure you. But for now, it suffices to leave the actuator and the data JPA support and the web support. What we're going to do is we're going to build a new application. So I'm going to go to the reservation service application, and I'm going to build a new application that manages data of type reservation. So reservation. And it's going to be a JPA entity, so I'll have a private long ID and a private string reservation name. Voila. It's going to be at ID, at generated value. All right. And we're going to have at entity. Now, there's my JPA entity. This is Java, though, so I need getters and setters and all that nonsense. So I'm going to go ahead and just use Lombok to make short work of that. It'll create artificial getters and setters and constructors and all that stuff for me. These are all annotations that are processed at compile time, so the compiler will do the work for me, so that by the time it gets to runtime, I actually have real methods on real objects, as opposed to, like, I don't know, something else. And I want to be able to save instances of this record into the database. So I'm going to create a repository, reservation repository, and it's going to extend the JPA repository, all right? It's going to be a repository that manages the persistence, the creation, the updating, and the life cycle of entities in the database. So a repository supports things like creating, reading, updating, deleting, etc. records. And we can see that by extending this interface, our framework, Spring here, is going to give us an object that implements that interface and provides all the support we need for doing, CRUD, create, read, update, delete, all that kind of stuff. You can even add custom finder methods. I can say find by reservation name, for example, and that'll be turned into a query at runtime of the form, select all from reservations where RN, where reservation name equals RN, right? Something like that. That's basically what's going to happen at runtime by convention. You can, of course, elect to override the method like so. You could do that, right? Now, I'm going to go ahead and write some data to the database. So I'm going to create a callback object here that implements the application runner interface. And this is a callback interface. When Spring sees this interface, it's going to say, oh, you want me to call the run method when the application gets started. And I'm going to use that callback as an opportunity to write some data to the database. So we'll go ahead and inject that into the constructor, and I'll go ahead and write some data. So stream.of, my name is Josh. It's so great to meet you. What's your name, buddy? How do you spell that, my friend? Very good. Nice to meet you. Where's the name from? That's a cool name. Brazil. Nice to meet you. Okay. I know you. You're trouble. Capital Charat. Yeah. What about you, buddy? What's your name? Hi. John. Very good. Nice to meet you, man. And what about you, buddy? How do you spell that? B, like B as in boy, and J as in Jerry. Okay, and M-I-C-H-E-L-L-E. Very good. Nice to meet you. You, miss? Yeah, just all four of you. Heather. K-A-T-H-E-R-I-N-E. Very good. Nice to meet you as well, all of you. And K-I-T-E, like that, or Y? Did I do it wrong? Okay, very good. Is that 8? Did I get to 8 yet? That's actually 9, isn't it? Well, let's get rid of the least useful one. Very good. So we're going to write each one of these to the database. I'm going to save each one as a reservation, passing in null for the ID and the name for the reservation name. And then I'm going to confirm that everything's been written to the database by getting back the data from the repository, just printing out everything as I see it there. All right, so we've got now the application. Let's go ahead and run this. I'll take some tea while that's happening. I think I've earned it. It's been a busy morning. All right, there we are. Look at that, huh? All 8 of us, we happy few on the console. That proves that it worked. Of course it worked. It was a demo. What were you expecting? It was always going to work. Instead, what I really wanted to focus on was this. This is the ASCII artwork that comes in our Spring Boot project. You see, all Spring Boot applications have amazing ASCII artwork. This ASCII artwork took a long time to get right, but you see, we in the Spring team have many people who are doctors, PhDs. So it makes me very happy to imagine that somewhere, somehow, there's a GitHub issue that says, darn it, we need good ASCII artwork. And I think you'll agree they did a great job. This took a long time to get right, but we're very proud of what we did. And it's for this reason I want to take a brief digression to talk about what I consider to be a very serious deficiency in the IntelliJ JetBrains product. See that checkbox? That checkbox, once clicked, suppresses the ASCII artwork. What the hell? That's a dumb feature. And so I did what all of us would have done in the same position. I'm not a hero. You don't have to thank me. I was just doing what any of us would have done. I went on the internet and I complained loudly. I cried on the internet. And so I sent a message to my friend Jan Sebron. Jan Sebron is a software developer by passion at IntelliJ IDEA JetBrains in Hanover, in Germany. And he sent me this message of hope, which I share with you here now, today. Don't worry, my friends. Hope springs eternal. And so it's for this reason that I also want to spend a moment and just talk about one of the most important features to ever be introduced into Spring, ever, period. You know, it's this new feature that we've got in Spring Boot 2.0, which I'm not showing you here today. I'm not showing you that. We don't have time to get into all those new features. I'm going to run this program, and it's going to show you a directory with another project that I've got on my desktop. You see it says banner.gif in the source main resources directory. Oh, well, do you see that? That's an animated banner. Sure, it adds like 30 seconds to your startup time. I don't care. Totally worth it. Totally worth it. So, anyway, we've got now amazing ASCII artwork. We've got data in the database. I want a REST API, so we'll go down here. I'm going to go ahead and add a new REST API. I'll say at REST controller, class reservation, REST controller. And we'll inject the repository there, reservation repository, at constructor, create an endpoint, endpoint, / reservations, collection, reservation, reservations, right? So this .reservation repository at find all, and we'll restart the application. I'll take some more tea. Okay, here we are. Localhost 8080 / reservations. Very good. Look at that. We got reservations. Okay? So we got a REST API. Are we done? Of course not, right? We have a number of concerns that we need to care about before we can deploy this into production. One of which is called observability. So what I'm going to do is I'm going to disable the security on this, or I could otherwise configure it, but let's just make it easy. I'm going to disable the security, and I'm going to go back to the build, and I'm going to reinstate, or if I haven't already, I'm going to reinstate the actuator. And the actuator serves to provide us with a set of HTTP endpoints that surface information about the application itself. And the reason we want to do this is because we want to support remediation. Remediation is the idea that when something goes wrong, as often as not at 3 in the morning for reasons I'll never understand, when something goes wrong in production, your pager, or rather these days, pager duty is going to go off, and you're going to be required to fix it. You're going to be required to get your service back online. And everything we can do to support that process is valuable. So we want to support that process by surfacing information about the process, right, about the application itself. So here's our application, reservations, but if I go to metrics, I get metrics. I get things about, metrics about the application, CPU, uptime, hosts, all that kind of stuff. I go to env, get the environment. I get system variables and system properties. I go to, what else do I got? Info, which is empty. You can put information like the build date and the build ID. You can go to trace, which gives you the trace log of the requests that have been made into the application, the timestamps, the headers, all of that. You've got health, which gives you the health status of the application, the different individual subsystems in the application, the file system, the database, etc., and whether they're up or not. And this returns, by the way, 200 status code in HTTP if it's okay, and it returns a 500 if there's something wrong. So all of this supports operationalability, right? How easily can I get the service up and running and then make sure it stays that way. So we've got now a service. We've got an individual service. We could deploy this to a cloud technology, something like Cloud Foundry, and that would make it very easy to now automate the things like racking and stacking infrastructure, right? How do I get the software up online and into a production environment? That's all taken care of with the cloud computing technology. So between Spring Boot, making it easy to build production-worthy software, and technologies like Cloud Foundry, making it easy to run and manage software, you've already gotten past that first pain. Now we can face that second one. The second one is, the complexities of building a distributed system. Thus far, I've showed you a very simple application, and I've changed one thing here in this property file, application.properties. This is a configuration file. Well, the property file is inbuilt into the jar. It's in source main resources application.properties. If I want to change anything, for example, suppose I want to point it on a different port, 8010 instead of 8080. Well, I have to recompile the jar to see that change reflected in the running application, which is okay, but it's a non-starter if I want to promote my application rather, from one environment to another, from dev to Q&A to staging to production, etc. So rather than do that, I want to keep the configuration external to the application, right? So we go here, cd downloads, cd reservation service, may even clean, install, right? skip tests because YOLO. Alrighty, now if I go here, I've got a so-called fat jar, right? 30 megabytes. This jar has everything I need to be able to deploy this application by itself, and I can run the application. I can say java-jar reservation service.jar, and there's the application. If I want to change the configuration, I can say java-d server.port equals 8030, for example, and that'll override the server.port property that I would have otherwise specified here. So you'll see the application spinning up here on port 830 or 8030. Whoops. Right, there it is there, port 8030. So that certainly works, but it's a little tedious. I have to copy and paste my configuration from one startup script to another. I have to, keep that in the startup script for the application itself. It doesn't help me in a number of use cases. Suppose I want to centralize the configuration instead of copying and pasting the configuration from one place to another. What if I want to support live reloading or reconfiguration of the configuration? And what if I want to audit the configuration, see who changes what and when, and then if necessary to roll it back, right? What if I want to support encryption, secure values, things like that? Well, for all these reasons and a number of others besides, I'm going to use something a bit more sophisticated. I'm going to use another microservice called the Spring Cloud Config Server that will actually manage access to a directory of configuration, which I've just cloned here on the desktop. So desktop config. Desktop config. There we are, a bunch of property files. So let's go ahead and stand up that new microservice. We're going to go to the start.spring.io. We're going to build a new microservice called the config service. Config server, hit generate. And that'll give us a zip file here, cd downloads, uao config service. And I'm going to then configure that to manage access to my directory of configuration. So server.port equals 8888. Spring.cloud.config.server.get.uri equals home /desktop/config, and the config service application at enable config server. There we are. So we'll start this one up, and that's going to answer questions. When another client comes along, it's going to ask the config server, would you give me the configuration, please, for the microservice called the reservation service? And when it does, it'll get a response that looks like this. This one. Right? So here is the configuration for this microservice called the reservation-service. It says that there are two sets of configuration from two different property files, one called reservation-service.properties and one called application.properties. All microservices will see the configuration in application.properties, but only the microservice called reservation-service will see the configuration in reservation-service.properties. So these two sets of configuration are squashed together to form one runtime configuration set. Now, I've got a number of things that I want to take advantage of here. I have got a port pointing me to port 8000, and I've got a message. Now this message, while appropriate for last month, is not appropriate now. So I need to change this. This is completely wrong. It's not appropriate anymore. So let's change our microservice. Let's revisit our microservice here and teach it to draw its configuration not from the application.properties in the jar itself, but from instead the config server, which we've got running on a separate port. In order to make that work, I'm going to bring in the Spring Cloud configuration client. I'm going to throw this away. I'll say Spring Cloud config URI equals HTTP localhost 8888. Now, this is actually the default. It's going to do that anyway. This is the default value, localhost 8888. So it's going to work even if I forget this. I only show you because I care. I'm a giver. That said, I'm not going to remember to do that for the rest of the demo, so just keep that in mind. You're going to have to override that if you want to point it to a different service. We're going to give our microservice a name as well, so it'll identify itself talking to the config server. And now we'll restart the application, we should see it start up on port 8000. But I also want to take advantage of that message, this message here. We want to take advantage of that message. So at REST controller, REST controller, class message REST controller, private final string message. All right, and add at value message at get mapping message. All right, so I've got a message here, and I'm just parroting out the value. I'm going to say return the message as it is in the config server. I can imagine wanting to change this message later on, though, so I'm going to make this bean refresh scoped, and then I'll restart. And what that's going to do is it's going to mean that I can now effect a change in the configuration and reconfigure that one bean in situ without having to reload the entire application. So let's prove that out. 8000/reservations. Is that going to work? Good. That seems to be okay. What about the message endpoint that we just created? There's that. Now, let's change the configuration here. We've got the configuration directory on the desktop. I'm going to open up this property file using reservation service.properties, and we'll say Aloha Hawaii. Okay. Extra exclamation mark so as to reinforce my credentials and authority on Reddit. Okay. Git status, git commit -a -m YOLO. All right. Now, if I go to the microservice, you can see that the config server is immediately aware of the updated configuration. But this has no idea, not yet. We need to tell it to redraw its configuration. We can do that using one of those aforementioned actuator endpoints. So we're going to send an empty HTTP post to the microservice on port 8000/refresh. So it's an empty post. I'm going to hit enter, and then I'm going to hit go. Ready, steady, 1, 2, 3, go. Ha! Refresh, right? As soon as that came back, that one bean was reconfigured. I didn't have to restart the process. I didn't have to, relaunch anything. I didn't have to do anything like that. I was able to reconfigure that one bean, the value that was injected into the configuration, right? So here's the message injected into the constructor, and I was able to read it. I was able to get the value out and return it in the endpoint. So that happened all in the blink of an eye. This supports things like feature flags. I can now decouple the release of software from the deployment of that software, right? I can actually have software that's latent in the software deployment artifact that isn't actually working. It's not active yet. And there's a flag I can toggle to turn it off or on. Because I have the config server, I have an ideal mechanism by which to introduce security. I can introduce security between the config client and this microservice, and I can introduce security between the config server and the Git repository that I used, right? This is one pattern that becomes very useful in a distributed system. Another one that becomes very useful is how easily can I find and work with other services. In a dynamic cloud-based environment, things will come and go based on demand and capacity. So I need to make it as easy for one thing to find another. We could use DNS on the network, right? We could use DNS to say, that's a service that lives over here. But DNS suffers from a number of limitations that make it a poor fit for very dynamic environments. One of which is that DNS doesn't answer all the questions that we want it to answer. It'll tell us where a thing is supposed to live, but it doesn't tell us if that thing is alive. It's a very macabre distinction, but it's still a distinction worth making. Knowing the address of something isn't the same as knowing if there's somebody alive in that unit, right? I need to know if that service is going to respond. I don't want to know what its IP is. I want to know if it's alive. And that's a very different question. I don't want to make a call that's not going to respond, and I'm going to sit waiting for a response forever. So here, I'm going to introduce a service registry. A service registry gives me the ability to decouple the location of a thing from its liveliness, and it gives me the ability to ask questions about the state of the system. There are a number of different service registries out there. There's a Apache Zookeeper, HashiCorp Console, Netflix Eureka, etcd, Cloud Foundry, Kubernetes. They all support this concept of service registration and discovery. I am going to go ahead and use Netflix's Eureka. It's a tried and true, very, very dependable service registry. And we're going to go ahead and bring in the config client support. We'll hit generate, and that'll give us a new zip file here. So cd this, UAO, Eureka-service, and we'll point the property file. Spring application name equals Eureka-service, Eureka service application @enable Eureka server. Now that's going to spin up on port 8761. It's going to draw its configuration from the config server, and our job now is to go back to our microservice and teach it to register itself in that server. So I'm going to say @enable discovery client, and we're going to bring in the Eureka client support. We have one interface that gives you a common abstraction to talk to all these different service registry implementations. So here's our Eureka service registry running on port 8761. You notice a few things about this. First of all, very well done mouse over. That mouse over took a year. It wasn't even the right logo for like 6 months. Anyway, the other thing is that there are no application instances registered, at least in that refresh. I just refreshed the page, and now there are an instance, right? There's our instance of the reservation service. It's on this IP, this service ID, and this port. It's advertising its location. Now other clients can connect to this service to discover where that service lives, right? This is the keeper of the state of the system. So now we can build a client to talk to this service, to our reservation service, by way of that service registry. And we're going to build a client called the reservation client. It's going to use the config client support. We're going to use the Eureka discovery support. We're going to use Zipkin for distributed tracing, Hystrix, the circuit breaker, Zool, the API gateway, microproxy. We're going to use Lombok. We're going to use the web support. We're going to use Actuator. And what else? I think that's enough. Is that enough? Config client, Feign maybe. Yeah, config, Eureka, Zipkin, Hystrix, Zool, Lombok, Web, Actuator, Feign, Hystrix. I feel like that's probably enough. Let's go ahead and hit generate, and we'll have a new client now. Open up this client. Now, we're not building a client just for the sake of building a client. That would be wasteful. We're building a client that's called an edge service. An edge service is the first port of call for requests coming into your application architecture from the outside. It is the first place where requests from actual clients like your iPhones and your PlayStations and your Xboxes and so on will enter. And it is the logical place to handle client-specific concerns like security or protocol and payload transformation and translation, routing, all these kinds of things that are client-specific. Handle them at the edge. That way you don't have to change all of the microservices that you've deployed into architecture. Your microservices might be implemented in different technologies. It might be of different makeup and composition. So you don't want to have to change all of those just to accommodate a new client. Plus, if you did have to do that, you'd have to spend all your time redeploying microservices, which is exactly the situation we don't want to be in, right? We don't want to have to ask other parts of the organization to change their code base just because you decided to add an HTML5 client or an iPhone client to the system. So we adapt those client-specific concerns here at the edge. So this edge service is going to talk to the registry. It's going to register itself. It can find other instances of the service thanks to its integration with the discovery client here as well. Now, one common thing that we want to do when we have an edge service is make it easy for clients to proxy the data back and forth between the outside and the downstream services. And one way to do that is to use the Zool proxy. Now, Zool, of course, was named for the monster from Ghostbusters. How many of you have ever seen Ghostbusters? That's Zool. That's Zool. You don't. It's just sad. He and I have watched it together. I was there. I know you've watched that movie. I was there. Anyway, Gazoon. So here's Zool. He's the guardian to the underworld, the gatekeeper in the movie. The gatekeeper. It's a gateway technology. He's the guardian of the gateway. Never mind. It'll come. It's fine. It's fine. Give it time. So there's that. And the application is now spun up on port 9999. So 999/reservation-service/reservations. This is creating a route for us automatically based on the service that's been registered in the service registry, right? There's the route, reservation-service, that's the context path. And that's exactly what we have here in the registry, reservation-service. This is done for us automatically. It's going to proxy the data directly for us. And all the other services that we have in the registry will also be available at this edge service, right? This is very convenient because now if I have, for example, an HTML5 client, HTML5 clients can't make requests to other origins. They have to, they run afoul of cross-origin request scripting limitations. So now I can proxy data back and forth from the client through the proxy into all the downstream services. And the cost of doing that was this one annotation. That's convenient. Now this is, if you have to blindly proxy things, this is a great way to do it. You can introduce things like rate limiting and metering and all that stuff using these Zool filters, right? You can create custom Zool filters and do all sorts of useful things there. But if you want to do something more interesting, if you want to translate or transform the request payloads and responses, then this is not just a proxy, a microproxy. This is actually an API gateway. You're actually doing some sort of semantic translation. And so to support that, let's go ahead and create a very simple reservation API adapter REST controller thing, okay? And you can see that I am nothing if not succinct. So we're going to go ahead and create a new endpoint that returns just the names. Just the names. We're going to strip away the surrounding JSON strata and just return the names from the downstream reservations endpoint, all right? So let's make that there we go. In order to make the call, we're going to use the Spring Framework REST template. Well, we could actually, right? We could use the REST template to make the call. The problem here, of course, is that REST template doesn't actually, the REST template is an HTTP client, and it's going to be used to resolve HTTP calls. But think about this endpoint here. I made a request here, and I got an instance back. I got the data back from that service. I have one instance of the service in the registry, right? So yeah, I got that instance back. But what if I had 2 or 5 or 1,000? What if there's like 1,000 instances of that service and they need to be load balanced? Since I've gotten rid of the load balancer, who does that, right? How do I decide what instance of that service I'm going to invoke here? That is all happening in process, in the client. The Edge service has a library called Ribbon. Ribbon is a client-side load balancer, and by default, it's using LRU, or least recently used load balancing, but it can do all sorts of other kinds of load balancing, like multi-tenancy aware load balancing, or data locality, or whatever you want. You can do all sorts of things there. Maybe you can say, I've got an OAuth token, and I want to pin the request to a particular node that has a particular token. That strategy, those strategies are all in the client and they're supported by Ribbon. I want the same thing here for the REST template. So in order to do that, I need to configure my REST template. I need to produce the bean that actually provides the REST template, and I need to tell Spring to contribute a load balancing interceptor. So load balanced, and that will work. Now I can write this code using the REST template. I can say this.rest template.exchange http / reservation -service / reservations. And I could complete this call. I can complete the call, but you get the idea. That would actually load balance the request before it actually gets made. It would call the registry. It would get back all the instances. It would pass all the instances to Ribbon. Ribbon would pick one, and then that's what that resolved IP is what would actually be used to make the request. All of that happens in the blink of an eye. This is a little low level for me, though. Actually, it works, but it's a little low level. I don't want to spend that much time when I'm writing my client code. I want the benefits of HTTP and all the routing and compression and all that stuff that I get from HTTP, but having to write all this message passing code at the lowest levels gets tedious if I have to duplicate it. So it's common for organizations to create clients, but you want those clients to be small and thin and reproducible. So one way to get that effect is to use Feign. Here's a reservation client implemented using Feign. So I'm going to say @Feign client reservation -service. I'm going to call the reservation service. And what I'm expecting back is a collection of reservations that I'm going to read. I'm going to tell it to make an HTTP GET call to the reservation service on the / reservations endpoint. In order for this to work, I need to add Feign. Now, Feign in English means to pretend or to act as, right? It means to pretend, right? It means to act as. So if you see an animal in the forest with its head cocked back and its tongue hanging out, and it's looking at you with one eye closed, one eye open, it's waiting for you to pass by, it's pretending to be dead. It's feigning death so that you'll leave it alone. It's terrified. It's not actually dead, though. It's feigning death. In the same way that WebSphere is not actually useful. It's just feigning utility because it's terrified and it wants you to leave it alone. So we're gonna use Feign here to create a client. I have a client here, but I need that type. I need that representation here. So I'm gonna go ahead and create a DTO, a client-side representation of that type. Now, this could be, I could copy and paste tediously the implementation from the server side, but I don't want to do that. That would end up, I would end up needlessly copying and pasting, or introducing rather a single, fragile single point of failure. I don't want to assume that I'm going to use JPA, for example. So, and I can't assume, for example, that I have a server-side type that is in Java. So instead, I'm going to use a client-side representation of the same thing, and I'm going to use that reservation client here. Okay. So, private final reservation client. Alrighty. Now, I'll say this.client.read.stream.map reservation, get reservation name, .collect, collectors.toList. All right. Now, there's our new endpoint. I'm going to restart. Localhost 9999 / reservations / names. Okay, whoops. There we are. So there's our endpoint, and that works in the happy path. Assuming I have one or more instance of that service in the registry, it's going to load balance across one of them. It's going to load balance by doing the same dance that we described before with Ribbon. It's going to find one or more instances. But what if we have 0 instances of the service in the registry? I can't load balance across 0 instances. That's a bit like trying to divide by 0. You know what 0 divided by 0 is? What is 0? Oops, nope, it's not going to work. It's not going to work. I need to have airplane mode off. That would have been something that a well-rested Josh would have known. What is 0 divided by 0?
you split them evenly among 0 friends. How many cookies does each person get? C. It doesn't make sense. And Cookie Monster is sad that there are no cookies. And you are sad that you have no friends.
It's true. It's true. Don't make Cookie Monster sad. Don't divide by 0. Don't try and load balance across 0 instances. You're going to get a big fat, ASCII art middle finger from the service if you try that, right? Don't do that. We need to understand that sufficiently distributed systems will fail. It's not a matter of if, it's a matter of when. And instead, we need to build our systems to degrade gracefully. One way to do that is to introduce a circuit breaker, @enable circuit breaker. And then there, with that done, we can create a fallback method. So public string fallback. Return new array list. And then we can say @Hystrix command fallback method equals fallback. And voila, right? So there's our fallback method. Now, if something should go wrong in this code, it's going to call that fallback method. Let's go ahead and restart this. I'll take some tea. Alrighty, so there's the happy path. That's working great. Now let's go kill the downstream service. Poor thing. Fare thee well. Okay, empty array list. I didn't get a 500 error, didn't get a stack trace. I got a nice empty array list. I controlled how we degraded. High-performing organizations will do this kind of thing all the time. They'll say, oh, well, you called the search engine, but it's not available right now. Here are some machine-learned recommendations from across the web. Is it what you wanted? No, but is it better than nothing? Of course. Infinitely better, right? Now, eventually, when you restart that service, it's going to percolate. It's going to re-register itself with the registry, and that's going to have a heartbeat event that'll get percolated out to the clients, and the clients will see that the service is now available, and the circuit breaker will allow data to go through. That circuit breaker is really smart. It keeps track of the state of the circuit. Right now, that circuit is the connection from my client to the other service. If there's an exception, the circuit opens. Because we don't want to call that service that's down all the time and overwhelm it. If it's down, it's down. We need to give it time to recover. That circuit breaker has a memory. That's why it's so valuable. It's not just a fancy try-catch handler, right? We're not just trying and catching logic. We're actually keeping state of the fact that it has failed before, and it's likely going to fail again. We want to invalidate. We want to switch that back to working again when we can, but we can't assume that. So there's enough sophistication in there that eventually, when you refresh the application, it'll work. It's healed itself, right? That circuit breaker gives us the ability to do that. Now, so far, we've looked at a number of different use cases. We've looked at how to build cloud-native applications that are robust, they're failure-tolerant, they're agile, they're easy to change, and they're observable. We looked at observability in terms of the individual node, the actuator endpoints. But that is not the only thing that we have to look at here, right? We have a distributed system, and that distributed system has emergent behavior that we can't appreciate by looking at individual nodes. So let's now turn, as we have in our waiting 5 or 6 minutes here, let's turn back to ways to observe the system as a whole. There are ways to understand the emergent behavior in the system by monitoring the flow of data from one node to another. One way to do that is to look at that circuit breaker. That circuit breaker represents the connection from one client to our service. If that circuit breaker is open, then by definition, the downstream service that we've called isn't responding or isn't doing the right thing. I can't change other people's terrible life decisions. I can't fix everybody else's code. I can't insert my monitoring tools and monitoring agents in other people's code bases, but I can monitor the flow of data from my service to theirs. And one way to do that is with that circuit breaker. So we're going to create the Hystrix dashboard here, and it's going to be a thing that will allow us to see the flow of data from one node to another through that circuit breaker. Okay, UAO Hystrix dashboard.zip. Now I'm going to point this to the config server. Spring application name equals Hystrix-dashboard. And we're going to go here to Hystrix dashboard application, @enable Hystrix dashboard, @enable discovery client, and we'll start this up. And what that's going to expect is a server-sent event heartbeat stream. It's a stream that gets generated for us on the service that has the circuit breaker, the edge service. It's a stream that gets generated for us, and that it goes on and on and on and on and on and on and on forever and ever and ever and ever. It has no end. It is endless, like the oceans and the stars and the skies and the bugs in your code. Just infinite. It has no end. So whatever you do, my friends, and I cannot stress this enough, whatever you do not curl this endpoint. So we're going to take this stream, and I'm going to take it to the Hystrix dashboard that we just created on hystrix.html. I'm going to paste it there. Hello. Hit monitor. And that gives us a circuit breaker visualization of the flow of data from that in that circuit breaker. So here we are, 99, whoops, localhost 99, reservation names, refresh, 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 refresh. And as I do that on the left, you can see the moving average trending ever upwards on the right. It's showing me that I've made 37 requests, 44, etc. It's a moving average. Everything is fine right now, but if I throttle the gas, it trends downwards, trends towards 0, right? The asymptote of 0. So I've got now a visualization of the conduction of data from one node to another through that circuit. The circuit is named after the method, which is called names. I can have multiple circuit breakers across multiple service instances, across multiple services. Also represented here, right? That's easy enough to do with Spring Cloud Turbine. But for now, since we've only got one circuit breaker and one instance, this will have to do. Another way to visualize the flow of data across the system is to use distributed tracing. And distributed tracing, in theory, is very simple. It says that for every single request that flows through any node in the system, as long as I have some way of correlating that request, of tagging it and then following the progression of that tag later on, then I can visualize and I can time the movement of messages across the system. This is, in theory, very simple, but in practice, it's a lot of work. It's a lot of pain because you have to update. Anywhere where a message leaves or enters the system, you have to have code, right? Anywhere a message leaves via messaging or REST or HTTP or MVC, you have to have that code yourself. So it gets very tedious. So instead, we're going to use the abstraction called Spring Cloud Sleuth. Sleuth is our distributed tracing framework. We're going to use an implementation of it called Zipkin, which is a project from Twitter where Chris works, right? OpenZipkin is an open source project. We are lucky enough to have on the Spring Cloud team people from both Netflix and from Twitter who are committers and contributors that help make it a compelling experience for developers trying to build distributed systems. So let's go ahead and I just realized I forgot one dependency here, Zipkin server. Okay. And we're going to go here at enable Zipkin server. At enable discovery client, and you notice that when I added Zipkin server, it says IO Zipkin Java Zipkin server, and then it says here at enable Zipkin server. At enable Zipkin server is a Spring Boot application, Spring Boot annotation. You see the Zipkin API, the REST API, is written in Spring Boot. Okay, so here we go. At enable Zipkin server. All of my other microservices, the reservation service. I'm going to change it to, I'm going to ensure that it has on its class path Spring Cloud Starter Client, Starter Zipkin. All right. So there we go. That's the Zipkin client that allow it to talk to our Zipkin service. Okay. Let's just make sure we reservation client. Restart. Oh, it already had it. Good. Never mind. So restart that one. Now, localhost 9999/reservation/names. Are we happy? Waiting for it to percolate. Ah. Oh, that's the circuit breaker dashboard. Service. Are you not happy? So, not sure what that is about, but 9411. 9411. Oh, I didn't. Oh, now I know what I did. Zipkin service. Spring application name equals Zipkin -service. That explains why I was so confused. Okay, so restart. Also, notice that the Zipkin project itself has good ASCII artwork. This is a thing, friends. Okay, 9411. Good. Zipkin. The Zipkin server is up and running. It's telling us that we have a number of different endpoints across our different services. Let's go ahead and There we go. If I make requests from the client to the service, you can see that the data is coming through. If I go now here, it shows me that the requests have gone through different endpoints. I go to the names endpoint, for example, hit find trace, and I can see that there have been a number of different requests that have gone through these different endpoints. Click on any one of them, and I can see that a message arrives on the reservation client, hit the reservation names endpoint, and then it left and went to the reservations endpoint. I can see the trace, the in and out, the ingress and egress of each message in the flow as well here, right? So with these tools, I have a number of ways to look at the movement of data from one node to another, to see the emergent behavior, to understand that the map is far less than the terrain, right? The actual experience that you'd get on the ground, or in this case in production, is much more than you'd get by looking at the architecture diagram of the production system. So my friends, we've looked today at ever so briefly just at a number of different things that you can use to build distributed systems. I wish we had more time. If we had more time, we'd actually get into the weeds a little bit. You know, we've just scratched the surface. We've looked at a photo of somebody scratching the surface of something, really. We haven't even scratched the surface ourselves. We have covered just the faintest list of things that we could have looked at. We could have covered so much more. If we had more time, we would have talked about federated security and single sign-on using Spring Cloud Security. If we had more time, we talked about eventual consistency and messaging using Spring Cloud Stream. If we had more time, we talked about orchestration, service orchestration, and distribution with Spring Cloud Dataflow. If we had more time, we'd talk about microservices testing. You know, how to invert the testing pyramid so that all these microservice calls are not integration tests, or at least they don't feel like they're integration tests. You can get the benefit of working with things that are actually in agreement with each other without having to stand up your whole architecture using Spring Cloud Contract. If we had more time, we'd talk about if we had more time, we'd talk about reactive programming and you know, all the support there in Spring Boot 2.0. If we had more time, we'd talk about serverless and functions as a service using Project Riff and Spring Cloud Function. Right? If we had more time, we'd talk about all these things and so much more, but I'm afraid, my friends, that we're out of time. So I want to thank you for your time, and if you have any more questions, don't hesitate to find me anywhere. I'm certainly here. I mean, I'm the idiot with a spring t-shirt on. So thank you very much. I hope you got something out of it. Cheers. You know, bye. Okay.